Okay, so now let's do a question involving free fall and gravity. So there was this basketball player named Spudd Webb, and he was one of the shortest players in the NBA. He had one of the largest actual jumps. He was able to jump 110 centimeters off the ground. So what we're interested in is if he were jumping just free falling in gravity, what speed would he have to leave the ground with in order to make this jump? So as with any other problem, the first thing we're going to do in attacking this is to draw a picture. So since it's a free fall type of question, we're going to draw a vertical axis, place our origin, say, down at the ground, where he leaves the ground. And let's just keep track of his feet. So his feet start out, say, at the ground, and he's moving up with some initial velocity. And let's avoid the complications with the fact that he's bending his knees and jumping. We're just going to look at his feet as he's jumping and assume that he's just a particle, a dot, as he's jumping. And at some point, he's going to reach his maximum height, where his feet are 110 centimeters off the ground. Or, in other words, he'll be 1.1 meters off the ground. And at that maximum point, we know that his final y velocity will be 0 meters per second. There are some other things maybe we could label here. We know that the initial time, well, we could label the initial time as 0 seconds. We don't know anything about the final time. So we'll leave that as an unknown. We don't know what the initial velocity is. That's what we want to find. We do know, however, that there is an acceleration as Spudd Webb is jumping, and it's in the negative y direction, and it has magnitude of g. Okay, so let's just make a quick list of the things we know and the things we don't know. So the things we know the initial y position, we know the final y position, we know the final y velocity, and we know the y acceleration. And in fact, we know the initial time. What we don't know, well, we don't know the final time. We don't know the initial y velocity. And what we're after, ultimately at the end of the day, is that initial y velocity. That's what we want to find. Okay, so what we ultimately want to do is see if we can find that initial y velocity given the things we know. And while we don't know the final time, we might not need that just yet. So let's see if we can find a way to solve for the initial y velocity using just what we have. So when we solve this, let's find something that involves all things we know except for VIY. And well, one expression that will do that is the final y velocity squared is equal to the initial y velocity squared plus 2 times the y acceleration times the displacement in the y direction. And we can use this to solve for VIY, the initial velocity in the y direction. So let's just take some steps on that. So VIY squared should be equal to VFY squared minus 2AY delta y. And then we can take a square root. So that VIY is the square root of VFY squared minus 2AY delta y. And now we're ready to plug in some numbers and see if we can get some kind of answer out at the end of the day before we evaluate whether it makes sense. And so plugging in the final velocity in the y direction is 0 meters per second squared, which will ultimately give us 0. We have minus 2, well, minus 9.8 meters per second squared. And then the delta y is the final position in the y direction minus the initial position. So the 1.1 meters minus 0 meters. And so the 0 meters per second squared is just 0. Notice that there's 2 minus signs here, so they cancel to make a plus sign, so that everything inside the square root is positive, which is good. We don't want an imaginary velocity. I think that might be bad. And to choose significant figures, we get that the initial y velocity is 4.6 meters per second. Now, it's kind of hard to evaluate whether that really makes sense because we don't really have a good feel for a typical speed at which a basketball player will jump. Something we're more used to is the hang time. So let's evaluate this answer by looking at the hang time. Well, the time to get to the top of the jump will be, that would be the TF that we noted earlier. So let's find TF. Well, we can find TF by using the fact that the final velocity is equal to the initial velocity plus the acceleration times the change in time, where that change in time, delta t, is the final time minus the initial time. Well, the initial time is 0, so this is just the final time. Okay, so then we find that TF is the final velocity minus the initial velocity over the y acceleration. And so we have 0 meters per second minus 4.6 meters per second over negative 9.80 meters per second squared. So ultimately we get that the time to get to the top of his jump is about half of a second, 0.47 seconds. Now that's just the time to get to the top. The hang time should really be about twice this. And so the real hang time is somewhere of the order of about a second. And that seems right. So it seems like the initial y velocity of somewhere around 4.6 seconds, which is what we found here, seems like a reasonable result for Spudd Webb jumping up to a height of about 1.1 meters.